Hey, what's up guys, and welcome in a new video. In this video we will discover what is a dynamic provisioner and a dynamic provisioning based on NFS. So don't forget to subscribe to the channel to not miss the next video, like and comment this one to support me. And in this video, the first thing that we need to do is just a little reminder because we have already seen this schema, this diagram, to explain what is a dynamic provisioning. So how it works. So the main purpose about the dynamic provisioning, of course, is to mount at the end into a deployment a persistent volume claim. And on the other side, of course, we need to have a persistent volume. And this persistent volume just provides, for example, NFS storage or cloud provider storage or host path with a simple disk, for example. But with the dynamic provisioning, how it works, this is really simple. When you install a provisioner inside your Kubernetes cluster, you need to install first a dedicated application, and this application just have a look on the storage class and the usage about the storage class, because when you install a provisioner, you install also a storage class aside of it. And when you use a persistent volume claim and you use into it this storage class provided by the provisioner that you installed inside the cluster, the provisioner just check the storage class usage and create automatically the persistent volume that you need to use for your persistent volume claim. So this is what we will need to do. The first thing, of course, we need to have an NFS server. So we will install it inside, just aside of our Kubernetes cluster, like in the previous video. And after that, we will install our dynamic provisioner. So you will see it's really easy to do it. We need to install, of course, the storage class, and the application just need to configure well this application. For example, to set our NFS server, where we can find our NFS server. Of course, in our case, it's just the IP about our NFS server. And after that, we will just create a new PVC with this storage class, and after that we will use this PVC inside a deployment. So let's go. Yes, for the next video we will use WordPress and just a little demo with WordPress based on practical exercise. Let's go. The first thing that we need to do is to install on our, and this is on the right terminal, our NFS server. So to do that, I can take the note. You can go directly inside the video description. You will have all directory that we have inside a GitHub repository, a GitLab repository, and you can of course reuse all script that we have for each video. You can see here we are at the video 33, but you can check, but you have all previous videos. So let's go. The first thing that we need to do, it's to install the NFS kernel server, to just install what we need for the NFS server. The second thing, to create a directory where we want to store on our NFS the data into it. The third thing is to set our configuration about our NFS server. So we want to serve the /srv/data directory and we allow all IPs inside this subnetwork to use this directory. And after that, of course, we can have a look inside the configuration. We have these new lines into it, and we can just run and restart here the NFS server to be sure that it's running. And after that, we can use export ifs -a, and we can run also export fs without sudo because we are already root, and we can see, yes, now our NFS server provides the /srv data for the entire subnetwork. Okay, after that, yes, to be sure, but this is ready, not production ready, but we ensure that all users can use this directory, but don't make it on production, of course. After that, you need to install the NFS client. So this is NFS common package on the Kubernetes cluster. If you have only one server, like us, you can just install it on only one server. But if you have multiple servers, multiple workers, you need to install it on all workers. Yes. And after that, we can download the NFS subdir external provisioner based on the GitHub repository, and we can store it in NFS provisioner directory. So let's go. I can, yes, zoom like that into it. So we download it. We can go inside it, I think, click here. And we can go inside the deploy, if I remember well. Okay, and then so we can just do like that. We can create a dedicated namespace to store our NFS provisioner in our Kubernetes cluster. Okay, so we can switch to go into it if you want, maybe like that. Yes, we haven't. Okay, we haven't Kubernetes, but it's not really useful. Okay, now we are, of course, in NFS provisioner in /deploy directory, and after that, we need to change the configuration about the airbag and the deployment. And to do that, we use sed, and we want to set the namespace to say, hey, it's an NFS system namespace that where I want to deploy our NFS provisioner. So please push it into. So where I am? Yes, I need to do it like here. Okay, and I can go into deploy, and into deploy now we need to kubectl apply for the airbag and for the class, the storage class, like that. So what we will have, we have created the NFS, so the service account, the cluster role binding, the role binding, and our storage class. So that means that now if I use kubectl get sc for storage class, I can see now we have NFS client storage class. Okay, but we haven't deployed our provisioner, and to do that, the first thing that we need to do is to edit the deployment.yml. So let's go deployment.yml like that, and I need to set where we can find our NFS server. Here, for example, with this IP, what is the IP? So we can check on the right terminal, like that. We are on this IP, okay. And we need also to change the path, because by default you can see we are in IFS Kubernetes, so it's not a good path for us. /data, because yes, this is /srv/data here, and we need to change also here the same thing. So yes, I can change the IP too, and I need to set /srv/data like that. Okay, so now I can kubectl apply for our deployment. Kubectl apply -f deployment like that, and if I check in kubectl get node, but in the namespace dedicated about our, so I don't remember what is so this is NFS system, if I remember well. No, kubectl get ns. So this is NFS system, yes. Get pod, sorry, get pod, and our provisioner is up and running. Cool. So now we can use it, and we can use the storage class, not directly the provisioner, but the storage class. And to do that, we can I can get all. Yes, it's good. And yes, now we can test it. So to test it, what we can do, the first thing that we need to do is to create a persistent volume claim, but you can see here that we specify the storage class name into specifications with our storage class, our new storage class, so nfs-client. So let's go, and we require 1 GB of storage. Okay, and I push it, so I can go in another namespace, for example. So we are in the default namespace, if I remember well. Yes, it's good, and we can apply. Okay, so now we have the kubectl, we have the PVC, and PVC is here and used by the NFS client. If I check kubeget PV now, and automatically we have our PV, and you can see here we have an ID created by the local path provisioner, and the claim, and we have of course our persistent volume claim named Postgres inside the default namespace. Okay, but we need to use it, and to use it we need to create a deployment and use the persistent volume claim into it. So how to do that? So this is like in the previous video, if I remember well. The first thing that we need to do inside the specifications about the deployment, we need to specify into volumes that we want to create new volumes inside the deployment, and to mount into it a persistent volume claim based on the name about our persistent volume claim. And inside the containers, but inside the main container that we have the volume mount key, and inside it we say that we want to mount the Postgres data, because the name of the volume is Postgres data, inside the varlib PostgreSQL and data. So we can do it, and normally it will be good. Okay, so it seems to be good, I think. Sorry, I need to check. Okay, it's ongoing. So we need to download the image first, and after that normally it will be good. I can kubectl describe pod to be sure that we haven't issue on it. Normally it's good because it started. Yes, it's good. And now we can use what we used in the previous video, like that. We can go into this PV, and in the NFS, no, I don't remember, in NFS maybe. Yes, we can reuse our kubectl run --rm, and this is our Postgres client, like here. And we can use it, and then we can check the Postgres user. This is admin, and the Postgres password. So this is password also, so I can, so that take a few seconds to download the Docker image, and it's good now. I can use psql like that, and we can use so we haven't we haven't service to provide our Postgres, so we can create our service with kubectl expose like that. And what we want to expose the deployment name Postgres. So this is the name about yes, this is Postgres, it's okay. Postgres, and we want to expose the port, yes, this port. I can check what we did in the previous video for the service. Where is the service here? Yes, this is this one, port and target port, just to be sure to not have any issue during the creation. So it's okay, and now we can, yes, run again this Postgres client, and now we can use psql-h, the name about our service, so this is Postgres, and the user in uppercase, the name of our user, and we can use password. Yes, we need to specify the database like that, and the password like that. Maybe I make a little mistake, and it's good. We are inside the database, so we can create a new table, for example T1, and like that I can make ID in hint, and I can push some data into it, into T1 table based on values, and we can store, for example, the first one is 1, second 2, 3, and we can select, to be sure, select star from T1, and you can see we have our value. So now we can remove our deployment, so kubectl get deploy, and we can, for example, kubectl scale deploy to be sure that we persist whole data inside the NFS server automatically, and Postgres, and the replica, we want to have 0 replica. In check we haven't any pod inside our cluster, so it's cool. And now we can scale our to 1 replica like that. Okay, I can check it's okay, and now we can run again our client like that, and SQL-H, the Postgres service, -u for the admin, -d and our database. And if I check, it's okay. And now we can run again the select star from T1 like that. And we haven't lost our data, so it's cool. Don't forget, you can subscribe to the channel to not miss the next video, like and comment this one, and see you in the next one. Bye bye.